Hello everyone. Uh, I'm here to present about the article titled BanSpEmo, a Bangla audio dataset for speech emotion recognition and its baseline evaluation. This article is submitted in the Indonesian Journal of Electrical Engineering and Computer Science. The paper ID is 39012. There are three authors and I am MD Gulzar Hussain to present this article. The contents of this article I will cover in this presentation. At first the introduction, then some literature review on the datasets found in speech emotion recognition in Bangla language, and the description of our BanSpEmo dataset, then the methodology for baseline evaluation, then the result analysis and some future work which can be done later on this research. Speech emotion recognition is a key area in audio and speech processing. It's very important because it's very critical in human-computer interaction and mental health monitoring and robotics fields. Many progress has been achieved in this field for a widely used languages like English, Chinese, and some other widely used languages. But like Bangla and Hindi and Urdu, these are not so much rich. So our the Bangla is a spoken language about 250 million peoples globally. So it's very important to develop a speech emotion recognition in Bangla language, which will be very helpful for the researchers who works on speech emotion recognition field in Bangla language. There are only a few publicly available datasets now. These are the four datasets until we found to on Bangla speech emotion recognition field. The first one, the latest one, is in 2023. It's named as KBES, which is developed with only 900 recordings. And the limitation for this dataset is the number of recordings are very limited, but it's okay. But it's also have a problem that the gender is not balanced in these recorded dataset. In 2022, the sub-ESCO dataset was developed, which have many number of recordings, but there is a limitation that purely neutral sentences are uttered with different emotions, which is difficult to express the different type of emotions because the sentence are limited with only neutral emotion, not any specific emotion. In 2022, another dataset called Bangla SER was developed of 1,467 recordings. It also have a limitation that number of sentences for uttering and number of recording is very limited. So they just used a very few number of sentences. In 2022, another data set was developed for the emotion speech recognition with 452 recordings. The number of recordings is very limited and the annotation process was not explained, and also it was not gender balanced. So all these four data sets have some limitations. So our contribution is to develop a new dataset on Bangla language in speech emotion to overcome those limitations. So we developed a Bangla speech emotion dataset BanSpEmo, which is diversified in Bangla for emotion from voice It comprises 12 distinct sentences uttered by 22 native speakers to represent 6 desired emotions, and it was also gender balanced. The total duration of the dataset is 1 hour 23 minutes. This research also shows an investigation of logistic regression, support vector machines, and multinomial naive Bayes algorithms against a few well-known audio features to evaluate their efficiency in classifying emotions in Bangla speech. After analyzing the result, we discovered each algorithm's performance, showing useful information about their usability for SER tasks in Bangla language. So, the main part of our work is developing the dataset. Our dataset comprises voice recording from 22 native speakers with an equal distribution of 11 males and 11 females, where we can see that the gender balance was maintained. The duration of the recording varies between 3 to 12 seconds. It is based on the length of the sentences. It also focuses on data which are collected from individuals who are aged between 20 and 25. Every sentence divided in two sets. There were 12 sentences. We have already mentioned in previous slide. So 6 sentences are in set 1 and another 6 is another set. So 6 sentences, we consider that every sentence have one repetition and in 6 emotions, and the first set was spoken by or recorded by 18 speakers, and the second set was recorded by remaining 4 speakers. So the total number of recordings in this dataset is 792 recordings. Here is the description of this dataset. We can see that here the number of sets or groups of the sentence is 2, and every group has 6 sentences. We recorded in 6 emotions: happiness, disgust, sadness, anger, surprises, and fear. So the total number of sentence or statement is 12 and total number of audio recordings is 792. We compared our dataset with some previously developed 3 datasets. One is Subscore where Bangla Asia and KBES. Here we can see that the actors are not trained in our dataset, and it's gender balanced and class balanced because every class have same number of recordings in our dataset. So you can see that in Subscore there is only 10 sentences are used, and in Bangla here only 3. KBES have have not mentioned the number of sentences they used, but in BanSpEmo we used 12 sentences, which increases the variety of the recordings and the lexiconal factor in the dataset. This is the system flow diagram of our next steps. At first, we clean the data because we have already developed a data set. Then we cleaned and pre-processed. Then we splitted the data set in training and testing sets. Then we used some features, body features for the classifiers to train the classifiers and to test the data. And then we evaluate the results by these matrices: accuracy, precision, recall, F1 scores. So the features used in this research is MFCC, spectrogram, JCR, RMSE, and chroma, which are commonly used and for audio analysis and processing and classification. These features are very important and commonly used. These features are capture the key audio features from the recordings to classify the emotions. So the result we found that this is the table which shows the accuracy, precision, recall for the SVM in 6 categories, where we can see that the accuracy, the average accuracy is 87.18%, which is pretty good for a new developed dataset. So here we can see that for SAT, it's the giving the higher precision, and for happy it's giving the higher recall, and F1 score is based in fear. Logistic regression have a little less accuracy, which is 84.45%, and we can see that for disgust it is showing the highest precision. Also, the equal precision is shown for the surprised emotion. And for recall, it's showing for the anger is the highest. And the F1 score is showing for the fear, sorry, for disgust. And multinomial naive bias, the accuracy a little low, which is 82.77%, which in which classification algorithm we can see that for happy it's giving the highest precision, and for fear, for anger it's giving the highest recall value, and for the happy emotion it's giving the highest F1 score with the anger emotion. If we analyze the confusion matrix of for the SVM classifier, we can see that anger is giving highest better result, but for the surprise it's giving very low, which can from which we can say that for surprise it's not working well. And for logistic regression it's same. For surprise it's not working so much good, but anger or the happiness it's working far more better. So SVM is better for anger, logistic regression is better for happy emotion. Multinomial naive Bayes is also performing better for anger emotion. So from the 3 confusion matrix, we can say that it is difficult for this algorithm to classify surprise as better classification result, but for anger or happiness or sadness, it's performing very good. If we go to the ROC curve with area under curve value, we can see that SVM is performing very good, and multinomial naive Bayes have also good one, but logistic regression is a little low. So we can see or say that SVM is performing well in all the area better than other 2 algorithms. So the performance of SVM, LR, and MNB on BanSpEmo dataset was analyzed for baseline evaluation in this research, and we found that SVM has the highest accuracy of 87.18%, which is pretty good. Though our work have been done, but have some limitation, and we can consider them in our future work. Like professional soundproof room was not utilized during the recording of the data set collection. So we can use a soundproof or better environment, but it's also a good thing because we can use some noise reduction or other kind of algorithms in the pre-processing steps if there is any noise or other sounds rather than the actual data recording. Though recently some dataset is available, increasing the size of this dataset might bring significant change in this field of study. So in future, our target is to increase the number of recording and increase of the number of statements is planned by us. These are the references of the dataset presented in this presentation. Thank you for listening me. I hope it will be very helpful for the researchers who want to work in the speech emotion recognition field in Bangla language. Thank you everyone for listening me.